We're recording now. So the email from Martin was asking a question about the mask, and can we find a way to dim the mask in the region of the galaxy? And there are a couple of ways we can have a go at doing that. So the first one is to use a painting tool. So we're going to start off with the final image from yesterday. We're going to try and create a mask. So we're going to just calculate or extract the luminance part of that image, and we'll take that as the thing we're trying to change. So there is as I mentioned earlier, Juan Cañero is philosophically opposed to any painting tools, and the only painting tool in there is under the painting, and it's a clone stamp. So you open up the clone stamp, you click the image that you want it to work on, to select it, and then what you do is you find a nice dark bit that you want to clone. You can zoom in and find it. You click on that, and then you can drag over to the bit you want to clone. And so what that will do is, you can see it just sort of clones that bit of the galaxy. Now, the only problem with that is that you'll find that there are bits of stars appearing. There you go. Okay. So if it's not terribly dark, as you move around, you'll find that the stars appear in there. So that is one way to do it, and it's worthwhile using, particularly for masks. You know, I often find that as somebody pointed out yesterday, the mask for the star mask often has the center of the galaxy there, and if you want to get rid of that, the best way to do it is with the clone mask. It's easy just to paint that over with black, and you can get rid of the center of the galaxy if you want to. So that's one way you could do it, but there is another way. So that the first thing we're going to do is to remove the stars of this mask. So we're going to go to the process menu and go to Pixel Math. And we're going to have the same expression as we used for the mask generation. So $T, capital T times open round bracket 1 minus star mask. And this time we're going to replace the target image. We're not going to create a new one. And if you take that and you drag it over, that then should remove the stars. The next thing we're going to do in the process image, under mask generation, is something called range selection. So we can open it up.
Sorry, which one was that again? That was under which menu?
Under mask, process.
Okay.
Mask generation, range selection. Okay. And then we're going to make that a real-time preview so that we can see what's happening. Okay. So, and now what we can do is drag the lower limit of that until we get down to the center of the galaxy. Okay. And now we probably want to make that selection a bit fuzzy. So that we can change, we can play with those, we can play with the smoothness. And they'll just left them with the core of the galaxy and the core of the two small companion galaxies. When you like what you've got, you can just press apply. Okay. So you've now got, whoops. You've now got a new mask from the range mask, which looks just like the core of the galaxy.
And did that name it automatically?
Yes, range mask, that's correct. Well, for some reason, I don't know why, it hasn't actually included the main part of the galaxy there.
Is it because you just got rid of it using your clone stamp from the previous exercise?
No, I deleted that.
Deleted it. Okay.
Yeah. Let me try that again. So, pixel math. All right, that's been done. Interesting. Let's have a look at the value at the center of the galaxy and see what's going on there. Oh, I think I know why this is going on. I think that's because when we use the, yeah, that's why. That's why we've done it. So let's go, we need to go back and fix the star mask. So if we open up the star mask, what we'll find is that there is something at the center of the galaxy.
Black hole.
Yeah, there are some things at the center of the galaxy. You can see there's a sort of very slight mask in the center of the galaxy there. And that's causing that center of the, because we then multiplied it by 1 minus the star mask, that's caused that to have a problem. So what we're going to do, we're going to use the clone mask to fix the star mask. So if we arrange them this way, we're going to drag that over to the star mask so that we've got the same color that we've got there, so that we can actually see that, and we're going to stretch the star mask as well. We're going to stretch the star mask so that we can actually see the stars in the center of the galaxy, which if we don't have it there, are quite hard to actually look at. So what we need to do is find a way to get rid of those stars there. And again, we can go back to, now we have to go back to the painting tool, clone stamp. So we press Control and over to the bit we want. And this time, we've got a bit more control over it. And if we're having problems, we can go back to press Control again. Just to where we're going to select it from. Okay, so we can gradually get rid of all the stars that we don't want in the center of the galaxy. When we're happy, just press the tick, and that will then make those changes permanent. Okay, so what we've now got is a star mask without that in place. What we need to do now is go back to our, undo the pixel math expression that we had on there. And now let's redo it. I think hopefully that will now have preserved it. Now we try the range selection. Still a bit low there. Right, let's fix this another way. So we're going to apply that. The main. Oops. We're going to apply that to that one, which gives us this new range mask. And then we're going to use the clone stamp again on that, just to fix it and paint it white. Okay, so if that's the bit of the galaxy we want to now protect, what we can do is take out HDRW mask. If we want to protect that, what we need to do is to multiply that by 1 minus the range mask. So again, go back to the pixel math expression again.
So the $T is effectively saying do it to the
Right.
selected image.
Okay, and if we do that, there we are. We've ended up with a mask, which has basically removed the galaxy cores. So then if we use that, we could then actually apply that and preserve the brightness in the galaxy.
Right. Yeah.
Okay. So you can do it. It's a bit more faffing around, but you can do it.
Yeah. So, yeah, star mask reduced the center of the galaxy. No, luminance mask reduced the center of the galaxy.
Use the luminance mask. Use a range selection to create a slightly tighter range of that.
Yeah.
And then multiply it by 1 minus. And the reason I took out the stars because the stars are bright, and therefore I didn't want to actually exclude those from the protection either. So.
Righty ho, thank you.
Okay, so it is possible, but it's a bit finicky.
Yeah.
But it's also good that there's some new tools that I don't use range selection very often. I do use clone stamp occasionally to fix a mask, but that's about it.
Yeah.
But I don't very often use the range mask. But there are tools there to allow you actually to create things which look just like the thing you wanted to try and do.
Right. Yeah, I just thought it'd be a way of sort of protecting the core.
Yeah.
Yeah.
So if we go back then, so let's try it out. So again, if you go to our History Explorer and we choose we can go back to after the histogram transformation. We can revert that, and we can take a clone of that. We can then apply Martin's new mask. And then we can apply let's go transform. Yeah, 7. There you go. So, yeah, it's not that great. It looks a bit artificial, and you've got all these sort of strange ringing in there. But I'm sure if you played around with it, you probably could have a better impact on it.
Isn't that the general problem when if you do something that's essentially non-computational, that you're just as much danger of creating artifacts as you are making it look prettier.
And certainly that's what Juan Camillo would argue as well. But it may just be that somebody who's better at it than me. I'm sure if you're better at Photoshop than me, you could probably find a way around it. There's also nothing to stop you taking stuff from PixInsight into Photoshop, doing something, and then bringing it back and continuing the processing.
Yeah, but it does raise that
I
philosophy.
suppose it'll import a TIFF, won't it? Yeah.
It's going to import and export TIFFs, yeah.
But there is still that question remains: is are you producing a representation of something's there, or are you using what's there as a basis, producing a pretty picture?
Yeah, and that's certainly what one Daniela would argue, that if you're doing something mathematically computational, he would argue that he calls it something like documentary astronomy or astroimaging, and so they've got this vague notion of a school of astroimaging, and that's one of their tenets they've got.
But there is a sense in which, as soon as you apply a stretch, you are changing what you would see into something what you would like to see.
That's also true, but he would argue that's okay because it's a mathematical prescription, and you've still got a one-to-one mapping.
So
From what you started with to what you end up with.
if it's deterministic, that's fine. But by that I mean doesn't involve aesthetics.
Yeah, that's what he would argue. Yes.
Yes.
Yeah, but I think that's
Personally, I think you should do whatever makes it look. It's as much as an art as a science. So just do whatever you think looks good. So what I thought we could do is then actually spend some time just actually sort of making some notes about what we actually did.
that's really helpful.
Yeah, that'd be very good. The bit that I think I'm most focused on is the star match process.
Okay.
Okay, and if I wasn't here yesterday,
Yep.
So I don't know what's discovered yesterday, but a thing that would help me, because I think there are two camps here. There are people who've used PixInsight before, and I think it's always very helpful to come to learning with some experience. But I'm in the pig ignorant game, and what would help me is if you like put the notes or the bullet points under a process that one might take from starting with a bunch of raw images and producing the most basic of finished articles. Because I think we covered all of that, but not necessarily in that order. And then I could, or I certainly feel that I could then use that to experiment with data and then work out where I've gone wrong.
Yeah,
That makes sense.
my intention is to do that. Is to sort of start from the beginning, describe the workflow, and add some notes where necessary.
Excellent.
That's not. Oh, that's Cambria. Yeah.
I've no idea what the text is.
Could you do it in Calibri because it's not the.
Oh dear.
There you go. Okay. So pre-processing. So can you remember what the first step was?
Blink.
Yeah. So image inspection.
Yep.
Okay. So what I'll do, if I can do this, is to make it bold as well. Is to highlight the tools. Okay. So if we remember, we started off with the process, image inspection, blink, and then we just opened up the images we wanted to look at. Shouldn't have done all of them, and that gives you and the only so once you've done that, there are two things you can then do. shouldn't have done all of them and make it too long. The first is that you've got these two. So there are two options. The first is compute an auto STF for the current image, then apply them to all the images. And you don't typically want to do that because you'll find each image wants its own one. So you want to do the one at the top, which is apply an automatic histogram transformation to all images. Because otherwise you'll find some are brighter and some are dimmer, and some you can't see at all. So that's the only trick. And then if you find some that you don't want for some reason, all you have to do is select them. And there's a button there which is move selected files to new locations. You select that, you select the location that they're going, and then it will move it. And actually and it will then get rid of those. So that's one way to just get rid of data which is no good. So what I'll try and do, if I can remember how to do this. I will try and take some screenshots, and then we'll use dynamic crop. Okay. And then hopefully we can paste that into our document. I'm glad that worked. I haven't tried that before.
Oh my.
And then if I knew how to do this, I could do this inside PowerPoint. So do we know how to insert just lines and things and labels inside Word?
Yes, if you go to insert,
Yeah.
There's text box on the just to your right, text box.
Yeah.
No, keep going. There we are. And then you have to. Then it tells you take the top one, top left hand one.
That one.
Yeah. And then what you need to do is under format, I think, make it so that it overlaps. But that's it. That'll do. That's fine.
What I was trying to do was put in a label, a sort of an arrow, so I could actually label some of these.
Well, if you replace that thing with a text.
Replace this one.
Sorry, yes, if you go, if you right click on that and, no, I think it's right clicking on the box rather than the text. Right click on that, format. No, sorry. Yes, it was on that one, sorry.
Format of the shape.
Well, it's to do with where text sits with relation, or so that it can sit on top of the object you've just imported.
Okay. I was looking to do was just to draw an arrow from here to here and then say what do you want.
Oh, in that case, go to insert and simply choose a drawing object. What is it? Oh, you haven't got them on there. Shapes. Shapes. Under drawing, keep there, and then choose an arrowed one. That's it. Perfect. And I think you start with there and you point. That's it. Yep.
Okay. Okay, so what we can do is make this in line with change wrap text in line with text. Yeah. Okay, and then we do another one. This is maybe to insert. I can just copy it now, can't I?
Yeah.
can say
that's it. Yep.
Okay. All right. Great. So that's the first thing. So 2. What's the next step? Remember the next step?
But
Scroll down the list. Or have you already blinked? Or have I
Already blinked.
Oh, export the list.
So the next stage is so this will, and you can remove files which are obviously problematic here. They've got plain in them or they just haven't worked for some reason. The next stage we use a subframe selector. Let's go back and find that. So process, image inspection, subframe selector. Okay, so you remember if you remember what we did here, we basically added files. We then measured them. To add them. So this tool is quite nice. It actually creates a cache of what you've done previously. So if it knows it's measured something before, you'd have to measure it again. We then added an approval station, an approval column. And then we went to output subframes. Okay. So again, let me try and screen print this. Let's try putting that in. Okay, so that's second step. Third step. You remember the next one?
oh, it's batch preprocessing, wasn't it?
Yeah, right. So batch preprocessing. So under script, batch preprocessing, and then batch preprocessing script. And again, we just added the files, added the ones we just selected. We added the bias and flat data because you had masters of those. This one isn't the CFA image, and we use the master bias and the master flats. We chose a reference image and an output image. Okay, I put them somewhere. And then we just hit run. So again, if I just take that one. Oh, I know why it's not working. It's not working. Right, now we do a crop once again.
Yeah.
And then we can then paste it again.
Colin, you might want to save your document as well, because I've noticed it unsaved so far. Save accidents.
Good thinking.
Unless it's and did you say that it sorted the optimum for the registration out itself?
This particular one doesn't. The weighted batch pre-processing does. This one doesn't.
Oh yeah. So you have to define one.
Yeah. Okay. Need to select. Okay. I'm not going to document that one. It's very similar to the first one. So what? Anybody remember the next one?
We're not doing very well, are we?
In terms of pre-processing?
That's basically the end of the pre-processing.
I was going to say, because once you've got there, you've kind of got your master file, haven't you?
That's right. So we basically finished pre-processing now.
Yeah.
So we are on to
so the first dynamic crop to get rid of any artifacts around the outside of your image.
Yeah.
Could you make that 3A rather than 4, because that's an alternate?
Okay, and now we're on to linear processing. So step 1 in linear processing is dynamic crop. Dynamic crop. Okay, let's try it. Let's see if we can do that. So again, we opened up. Oh no, actually, before we did that, there's another step which we forgot. So it's color combination.
Oh, cool. I was thinking one-shot color. Yeah.
Yeah. So let's go back to that. Okay, so if we go into here, again, so let's open up the 3 files. Images. Oh, what do you find? Files. Okay, so it's process, channel combination. We just choose the ones we want. So it's R, G, E. Okay. And that will give us our first view. So let's try that. Okay. Dynamic. So first one is that. Second one is dynamic crop, which removes the ragged edges. And this one, don't forget, and the important thing here is to save what we did before. So that we can then apply it to the luminance file as well. And you just do that by taking the triangle and dragging it off onto the desktop before applying it.
And if you iconize that, it's iconized with the same values, is it?
Which one, sorry?
Dynamic crop.
Dynamic
So
crop.
I mean, you could either do luminance and the RGB at the same time.
I don't think that works actually, because it's a dynamic indicator. I'm not sure if it works that way.
Oh, so yeah, no, so yeah.
We can try it.
No, don't worry. Don't worry. If there is a safe way of doing it, let's choose that one.
Well, we can try. We might as well experiment. No, hasn't done it. That's what I didn't think it would do. Whereas if we just drag it onto there, then we can do it. Yeah, so that works. So the only way to do it is to actually save it to the desktop.
I think that's where I fell down the other day, actually trying to crop several images, but the session only file once. So I didn't realise you could, or missed the bit where you save it to the desktop.
Yeah, all you're going to do is take that and drag it to the desktop, and that will save the parameters you want.
So once it's on the desktop, you can then drop that on any number of other images.
Exactly, yeah.
Right.
Presumably assuming they have enough pixels to actually crop rather than being small.
Yes.
I don't know how it doesn't allow you to do it several times. So each time it gets a bit smaller. So I don't quite know how it works. So
Oh, that's strange.
So
I'd have thought,
it's obviously just It's obviously recording somehow the number it removes.
Yes, you'd have thought it would have. It must be a scale parameters rather than absolute.
Yeah.
How odd.
Oh, right. Okay.
But yeah, we are got the two there. Right. So we'll get rid of the color spaces and we'll bring back dynamic crop. And again, we'll do the same thing. Print screen, Control V.
People inside using their internet today.
Probably less today, isn't it? They're all outside having a nice time.
What? They're not allowed to do that?
Oh, nice time, good heavens.
Get back inside.
Do something enjoyable like learning about PixInsight.
Right, absolutely.
I have to say, Colin, this is
That's Marty.
proving very useful, this bit.
Good.
Yeah. I think this is going to get it all into our heads a bit better.
Yeah, absolutely.
Insert caption. Okay. Okay, and we'll just make some notes here. Okay, very good. Right. So channel combination, dynamic crop. So at this point here, we can then talk about color balancing. Yep.
Yep.
Okay, so we've now got this. So remember what we did was we created preview on a dark spot. We then used background neutralization. We put our cursor over there to look at the sort of values that there are, and they're sort of less than 0.003, so we use that as the upper limit. And then we set the preview here to be the image we wanted. Just the preview of this, and then that now gives us a balance in the background, and you can see the numbers now down at 0.005, 0.004, and so on. And we'll just rename the image as well. Okay. So we'll do that same thing, the same trick. Why is that not working? Okay, so again, dynamic crop. create a small preview in a dark part of the image.
And then a little arrow to reference the image, I guess. From
Then
there.
read, place cursor to read out values, intensity values.
In preview.
Set to, yeah, read out intensity values. Preview to set upper limit. Set region of interest to preview. Okay. And the next step, can you remember the next step after background equalization?
Dynamic background extraction.
We've got color calibration yet.
Yeah.
We could have done that. We could have actually put in dynamic background diffraction up here.
Okay.
For background equalization. So
sorry, calibration.
So we could do that there. We could do dynamic extraction if needed. Okay. We can do that. Okay, so if you remember that, you select the image you want to apply it to, place some samples in dark patches around the image. Set the target correction to subtract, and then execute. Now, in this case, it will look very similar to the previous image because the background is quite neutral here. Okay, so we've gone from, you can see it's gone from 0.006 to 0.005. So it's a very, very small change across the image. These images are nice and dark and pretty flat. Okay, but I will capture that. And what you might also want to do, you might also want to capture this one as well, because you might want to apply the same parameters to the luminance. Okay. So if you then, once you've applied that to that one, you can cancel it, bring up the light luminance filter, and do the same thing. And then you can automatically apply that to the luminance filter as well. And again, you get very similar. You get this very slight increase in noise in numbers here from 0.005 down to 0.007. There's a very, very slight gradient in that corner of the image. Okay, so let's go capture.
You're right.
Good. All right. So, note. Is that okay for documenting that one? That's 3. Number 4 is background neutralization. Number 5 is color calibration. Again, what we did process color spaces. Where is that? It's not here anyway. Color calibration. Again, we applied a preview over the galaxy as well as having the previous preview. Again, we checked the numbers in the preview there, and the numbers go up to a set of 0.0007. Again, we select that to the preview. And this one we set to the preview of the galaxy. And then we apply that without structure detection collected. And that will then finish the color calibration. That looks a lot better, doesn't it? Particular one. Okay. Any questions about that step?
No.
Sorry, so you selected regions of interest in both the white reference and the background reference.
Yes, the white reference is basically the galaxy you're trying to image.
Right, okay.
Okay. Now, when we did Andromeda, it wasn't really possible to select out with a rectangular thing, so we left it blank and actually selected the whole image. But if you've got a nicely constrained galaxy, it's better just to have the balance the colors using the galaxy colors rather than the stars. If you've got a nebula, supposing you're a nice hydrogen nebula, it's nice and red, what you might want to do there is use the structure detection, which will take out the nebula and allow you just to match the colors on the stars. Or alternatively, you can use the photometric color calibration for a nebula.
Could I just ask a question on this one, Colin?
Sure, of course you
can. Something I don't think I really understood, and I was wondering about when we did it the other day. We've got the white reference and the background reference, but we've already set the background to be a uniform grey, or not have a colour tint. So what are we actually doing here? Are we adjusting the colour tint again, and the background will become non-grey again, as in line with the foreground, or
it uses the background colour in its calculations. So this is a way of telling it what the background color really is.
Okay. So after
you're not changing those numbers. You're not changing these numbers in here again. But it's a way of actually telling it what the background really is, so that it knows anything that's white in the background is a color it should consider in the white reference.
So it's hinging the things about the background color or background RGB values rather than.
Yeah, exactly. It's not. So it's not actually changing those. It's using those in a calculation.
Yeah.
So it's not changing the color of every pixel on in the image.
I don't think so. Well, it might do, but it does that basis. What it fundamentally does is it uses this as a way of getting input as to what the background looks like.
Okay. Okay. I'm going to have to read up on that a bit more, I think.
But that's what it does. That's what it's for.
Yeah.
Tim, you might find that if you opened, while you're doing that, if you opened histogram and just used that to observe what was happening.
Yeah.
I mean, I guess what you'd hope is that the shapes, particularly if you've got the tracking on, the shapes of the RGB curves, where they may have been slightly different, will get to be having their peaks more or less at the same point when you're doing that.
Yeah.
Is that right?
Yeah.
I wasn't really listening, Nick. I was too busy typing.
No, that's fine. That's fine.
No, I think I'm going to have a look at that when we've got a bit of leisure time. I'm going to have a look at that and perhaps compare the pixels in before and after images and that kind of thing, and see try to just understand what it's doing.
Okay. Great. So we've now got color balanced images. Yeah.
And I suppose there's the whatever number that was, A, which is alternatively used photometric color calibration.
Yeah. Okay. We have two. Okay, so on to the next thing. Insert page break. So the next thing we did was mask creation. Remember that?
Yep.
Yeah. So
back to the luminance.
back to the luminance, yeah. So the first thing we did was we created a clone of the luminance image to make a luminance mask. Once we applied the star mask to that. So the first step of this one star mask. Get rid of that. I'll get rid of that. So again, process, mask generation, star mask. And the thing we tinkered with there was scale, make sure the stars are big enough, and we tinkered with the midtones to make it to be 0.5. Okay, I can hear it's. You can see it's called Star Mask 1 here, because there's a star mask somewhere else. Let me go and get rid of those. Not just allow me to do this.
Sorry, is that a star mask in a different work area?
Yeah, I was already using the data we were using from M31. So I moved to a different workspace to do this, and I'd forgotten that actually I'd have all these masks already used. So let's just
sure.
But they were in workspace 1, were they?
Yeah, they're in workspace 1. Yeah.
So does it? So it adds a thing, even though it's working in workspace 2. It.
Yeah.
To avoid confusion. Yeah, yeah.
Yeah, because you can move that to workspace 1 if you wanted to.
Yeah.
And therefore, you know, the name is unique no matter which workspace you're in.
Yeah.
Okay. Yeah.
They're not independent of each other. Okay. So I'm gonna cheat and just call this star mask.
Watch out, Martin, you're about to be masked.
Yeah.
You are.
But then again, oh no, you're not.
Yeah. Right. So, and then we, again, for this one, if we remember, we had this with background stuff here. So we used the histogram transformation just to tinker with that. And we drag the black point up to get rid of the noise that we shouldn't have had there. Okay. So let me just bring out star mask. Star mask. That's such a good one. Got Martin's space over. That's better. Wrong one.
That's the dynamic crop.
Wrong one. Yeah, indeed. That's not helpful.
You need to move it in the home. Yes.
Let's get rid of that. That's the one. Right, let's try again. Okay, what was the next one we did?
HDR mask, HDRW mask.
We haven't done the luminous mask yet.
Oh, right, okay.
So that's the next one.
Yeah.
Okay, so there are several steps here. The first is
Clone the luminance.
luminance, that's it. And we stretch using histogram transformation.
Was that with STF and histogram transformation?
Yeah. Okay, so remember that?
Yep.
Yeah, so we started off taking a clone of the luminance, we stretched it using histogram transformation and the screen transfer function. To do that, we dragged the triangle from the SDF to the HT tool to copy the parameters. Once we stretched it, we used convolution to blur it, and then we used histogram transformation again to adjust the black point to take out unnecessary space and possibly increase values in the core of the object. We used the midpoint slider.
left-hand slider.
Were you just testing us there?
Sorry, yes, it's fun.
Waiting to see if we'd notice.
See if you know exactly. So you've now got the star mask. So again, we're going to create a clone. We're going to call that luminance mask. We are going to bring out the screen transfer function and the histogram transformation function. We're going to stretch that. We're going to drag the parameters down. We're going to apply that. We're then going to convolve it. To smear it a bit. And then we're going to go to preview, turn that on. Oh, that gives it a nice loop mask. Okay, what was the next step? Somebody else mentioned it earlier on.
HDR.
HDRW mask, that's right. So what we did there, we used pixel math. Star mask, HDR. Mask. And we applied that to the luminance mask. Yeah, and we can see now we've got that same thing. We've blotted out center of the galaxy. Well, that's okay, but we might want to fix that if we're doing it properly. But it's all right for this. So the next step, we've now created all the masks we need.
Just one other little thing. There is the expression checker, isn't there? We can pass it in there.
Yeah.
Just to test. What's it called? Expression editor. That can be tested.
Expression.
Test the, what's the word? Syntax.
Expression. Oh, yeah.
Yeah, syntax. Yeah, that's good.
Yeah.
That's the masks done.
Yeah.
Right. So we're still on linear processing. This might take a while.
This book you're writing.
This book, yeah, exactly. So what's next? The next stage is deconvolution. So,
And deconvolution is basically sharpening, isn't it? Because it's removing the impact of atmospherics. Yeah, yeah.
so again, if we go back to this, we'll get rid of some of this rubbish. Get some expressions.
Ah.
Someone's had a Damascus Road revelation.
Yeah.
Oh, it's Martin. Again.
I was tinkering with dynamic crop.
Ah. You can actually sort of rotate it, can't you? Is that what you found?
No, it was that you actually had to drag the triangle off of dynamic crop onto the desktop before you use it on the first image.
That's it. That's exactly right.
Because if you do it afterwards,
yeah,
it's already done it and says, I'm doing nothing.
Exactly. It's a bit of a pain, isn't it?
Totally.
Yeah. So remember, we created the PSF by clicking on a bunch of stars.
This is the one with masks added, isn't it?
So this one here is actually just creating the PSF, the point spread function.
Yes, but you're doing it to something which has got masks.
It doesn't really matter. It's because I've forgotten to create it.
Yeah, no, that's fine. Sorry, yeah, okay.
And then we remember we did it by amplitude. We got rid of things which were very dim. We got rid of things which are very bright. We then sorted by mean absolute difference. I looked at those. They all look all right, actually. We took an average to have a quick check at it, and then we created the PSF using the camera icon. Okay, so let's grab a photograph of that.
Is it worth encompassing all of those, because that includes the Ed memoir about the about which selections had been made, or is that going to
try and do? Yeah, in the text.
Ah, yeah, that's fine.
So Okay. The next step then is deconvolution.
Sorry, can you say that again?
Deconvolution, if you like.
I'm not an Amazon Echo.
So deconvolution was the next step. Okay.
HDR and ST, was it? Oh, was that frame selection again?
So again, we applied the HDRW mask to that.
Oh, yeah. It's under deconvolution. You clearly not one of your favorites.
It was. And it's deconvolution. So we use the external PSF. We have global deringing, which we set to 0.01. We have local deringing, which we set to the star mask. And then we tinker with a number of iterations. I think we chose 25 as the right number of iterations for this one. And we also played with it to get the right number of iterations and the global dark setting by using previews. Deconvolution. Dark. So it's a
Presumably, you also might usefully include some stars just in case the ringing is more evident around the stars.
Yes, that's right. You can play with it. There are typically stars everywhere, but yes.
Yeah.
Point. That's deconvolution. And print screen. Okay, right. On to the next one. That's deconvolution. What's next? Anyone remember the next thing?
Smoothing.
Smoothing. Yep.
I'm cheating. I'm looking at my notes.
So we've done sharpening and then we do smoothing. Can you remember the tool we used?
TGB denoise.
Yeah.
Denoise. That's it. So, oh, we haven't so much. We haven't done here is tell it about the mask we're using.
Sorry, I'm rattling some chocolate here.
Lucky you.
You should wait till Sunday. That's cheating.
Oh yeah.
Okay. So TGB denoise. All right. Okay. Look, I think this is going to take too long to go through the whole thing.
Yeah.
So I'm happy to have a go at doing this and bashing it out. But let's just go through the processing steps one by one, and I'll try and document them after. So you've got TGB denoise. What we did first of all, from that, was actually get some sense of how noisy the image was before we did anything to it. So again, we created a small preview. We looked at process image statistics. We chose that preview. Chose that. And we looked at the average deviation. We found the number was something like 8 times 10 to the minus 5. We then opened up TGB denoise. Again, we chose a preview to try it out on, something with some background as well as some structure. And we then, there we are, that's 8 times 10 to the minus 5. And we applied a luminance mask, inverted. And we typically find that when we do that, if we use the numbers that it says, we actually wipe out a whole bunch of interesting texture and structure in there. So I've typically found that the best thing to do is to move it down by a factor of 10. And then we get some nice smoothing of the background, but we don't actually lose any of the detail. And then we apply it to the image. And then we did the same thing to the luminance file, to the RGB image. And again, I've typically found that the same parameters work well for that file. Mask, invert mask. Right. So when we've done that, we've now finished the linear stage. We've balanced the colors, we've sharpened, we've smoothed, and now we're ready to enter the nonlinear processing stage. Yeah.
That's just smoothing the RGB, isn't it? Not sharpening the RGB.
Yeah, we haven't bothered to sharpen the RGB.
Oh, that's all right. Good.
The wisdom is that most of the texture is in the luminance part.
Luminance.
Yeah.
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 And so when we combine the luminance and the RGB later on, what it effectively does is take the color from the RGB and the luminance from the luminance flag, and it mixes the two together.
Sure.
I'm told that I haven't actually tried experimenting with deconvolution on the RGB image. I'm sure you could, but I haven't actually tried it.
So if you were using one-shot color,
yeah,
is it worthwhile extracting the luminance and then doing these processes on the luminance and then adding them back into your RGB later?
It might be worth trying that. Certainly that's what I've done when I typically do shoot a star cluster or globular cluster. I typically don't bother with luminance. I just do RGB, combine the three together, extract the luminance, and then I then do deconvolve the luminance and then combine it, add it back on later. So that's exactly what I do on a star cluster. I found that works well.
And when you combine, you're doing RGB combine, aren't you?
You're doing LRGB combine, combining the luminance with the RGB.
Yeah.
So the next stage is stretching. Wrong one. Histogram, screen transfer function, and histogram transformation. So again, we've done the same trick. We're going to drag down the numbers there. Drag it down and stretch and then delete. Same thing up there. Drag it down. Let's just check the number here. That's too low. We're going to drag that down. And do that. I'm just going to repeat it on this one. Okay. So histogram transformation, screen transformation, histogram transformation, and then we're going to combine the two, and we do that through using the color spaces, the LRGB combination. We get rid of the RGB because we're actually going to use that in the image there. We select the luminance file that we want to use, and we treat chrominance noise reduction, and we apply that to the RGB image.
Sorry, Colin, did you untick the RGB there?
You have to untick it, yeah.
Yeah, okay. Yeah, because it's a single entity, isn't it? Yeah.
That's right. It applies it to that one. If you don't, so if you actually specify, if you could, for example, you could actually extract those. You can actually split that up into three, and then add them in there, and it would then combine them.
Right. But as they're already combined, no point.
As they're already combined, there's no point.
Yeah.
Okay. And then normally that gives you, yeah, you can, if you zoom in on some of the structure. Yeah, you can see that defines the structure a lot more nicely when you've got the two combined. And that's partly because of the increased data in the luminance and partly because of the sharpening we've done on the luminance data.
Yeah. Okay.
So you do LRGB combination. And then we started to play. We applied the HDRW mask. Oops. And we used the multi-scale, where are we? HDR multi-scale transform. I think we used 7, I think, was it 7 or 6? I can't remember. We then created some previews on here to experiment.
We did 5, 6, and 7.
5, 6, and 7, thank you. Okay, so we experimented with those. I'm pretty sure we decided that 7 was the best, but it was still a bit much. Yeah, so I think we decided 7 was the best, and we used our friend Pixel Math to just multiply that by 0.75 to just reduce it slightly. So we do the same thing with the slightly reduced mask. And we can go between the 2 previous, see which one we like the best. Yeah. And I think the 100%, for me anyway, it flattened the image too much. So we stuck with a 0.75. But it looks much better than the previous, than the untreated one. And then we apply that same thing. When we got what we like, when we actually got to the stage of liking it, we then applied it to the main image. Okay. We then applied the luminance mask and we made the colors better. We went to the curves transformation, saturation, and we increased saturation a bit.
Why do you apply the luminance mask?
Because you don't really want to increase the color variation in the background. You only want to do it where the image is bright.
Okay.
Okay. So we kept going until the colors got a bit garish. Gee, that's not too bad. And then we might have applied a half one where we might have reset it and applied a slightly less saturation contrast until we actually got the colors we liked. Much. Yeah. Right, so we got the colors we liked, which was great. And then the final thing we wanted to do was back to our histogram transformation. And then what we wanted to do was just reduce the value of the background to make the galaxy pop out on the page. And that was it.
Perfect.
Okay, and then if we wanted to, we can save the file, save as. If you want to export it somewhere, you can save it as M81 as an RGB. And if you do that, it'll give you some options. Come on. You want the quality to be set at 100, and you want it to include the ICC profile. And if you do that, it'll look like that when you actually post it on a website somewhere.
So what's the second one? The ICC
profile. It's the sort of color profile of your monitor. If you've got a color profile saved on your monitor, which I do, it will save all that data inside there to make sure that color is then replicated on a website, assuming the website deals with the ICC data. So AstroBin didn't used to deal with that, and if you had a non-standard ICC profile, you would end up with some strange-looking files. But it now deals with it properly.
Just why does that have preview 011 in the top left-hand corner?
Did I apply it to the preview? Oh, I think it's basically just the fact that there are previews there.
Oh, I see. Yeah, sure. Yep.
Okay.
Yep.
So, any more questions before we close? I'm happy to take questions, and I'm happy to. I'll try and finish that documentation as well.
that was
Thank you.
I actually like the colours on this one better than the one we did yesterday.
yes. Colin, thank you very much. And today has glued the whole thing together for me. Stunning. Thank you very much indeed.
Yeah.
You're very welcome.
Brilliant. Thanks ever so much.
Yes, thank you. Yeah.
And
really
when I've finished this, I will send Max the video, and I will also send you all the finished documentation. But it may take a couple of days.
No worries. It'll be a couple of days before we're ready, I think.
Brilliant. Thank you very much.
Thank you.
Thank you very much.
Yeah.
Have a great weekend.
Thank you.
Everybody.
Bye bye.
Cheers all.
Bye.
Okay.